VXLAN or virtual extensible LAN. They have been defined in RFC 7348, and we need them because of the exponential growth in data center. Not only that, they have been large scale data center in terms of their square foot area on the ground, but also the number of machines that they are hosting inside. Not only that, there are physical machines. Now hundreds of thousands of physical machines could be inside, but also those machines are carrying virtual machines. Like one physical server could have many virtual machines, and that could lead to even more numbers. And all those machines might be requiring different VLANs. Now we know that VLAN has only 12 bits, which can give us a number of 4096. Out of these, most of the platforms are only supporting 4094. So this is the possible VLANs out of this 12-bit value that you can run in a single domain environment. But this value is quite short compared to the needs of the modern data centers. The second thing that VXLAN helps us, or I should say that is the shortcoming of the traditional LAN environment, is that to make it loop free, you would be running some form of STP. It would be either RSTP or MSTP, whatever, but it will be that many of the links will be blocked to provide you loop free topology. You can run, of course, per VLAN based STPs, but that is not an efficient solution anyways. It's just a makeshift arrangement. We need something more robust, more efficient. Another thing regarding the requirement for VXLAN is that the tenants or the subscribers or the customers that would be utilizing your services or hosting their servers either through physical or through virtual machines into your data center, they would be requiring VLANs. And not only they would be requiring VLANs, they might be saying that they want their own layer 2 environment, which would also mean that they would be needing their own VLANs. So it is quite possible that many customers would be having the similar number of VLANs, like maybe VLAN 1, 2, 3, 4 for let's say 10 customers. But that would not be possible because that would be conflicting VLANs. So you are stuck there again, that you cannot offer the same VLAN to multiple customers. Another solution is that maybe you can have layer 3 connectivity in your data network. That instead of layer 2, this is, let's say, your racks mounted on the floor, and these are top of the rack. They are switches. These are called as top of the rack switches, TOR switches, and let's say they are connected to spine switches, which are like backbone switches in this fashion to provide redundancy. And similarly for this one as well. So these top of the rack switches, they have, like, let's say, layer 3 interface here and layer 3 interface here and all the way here. Now that will be limiting the loop scenario because we'll not be running STP within the switches. So we can use efficiently all the links using layer 3. But then the problem would be that if, let's say, you have tenants here, let's say this is a tenant whose machine is hosted into this server in this rack, and similarly another tenant here whose machines are hosted into this rack, and they want plain layer 2. Since this is all layer 3 between the switches, layer 2 will not be able to pass these switches unless you do some kind of encapsulation, and VXLAN luckily provides us the same thing. Okay, so what does it actually do? Well, VXLAN, it takes the Ethernet frame, normal Ethernet frame, and it, so let's say this is your Ethernet frame, we call it original, and it encapsulates with a VXLAN. The important field in the VXLAN, of course, there are not that many, but the very important one is the VNI, which stands for VXLAN Network Identifier. It is a 24-bit field, 24-bit, and 24-bit value it gives you a potential of 16 million unique combinations, which essentially can translate to 16 million, you can say, tags or values in your data center. So you see this one would be a lot bigger than this mere 4094. It means that you can have 16 million unique identifiers in your data center, or 16 million unique frame types or service types in your data center, which is a lot more value than this 4094. This VXLAN is encapsulated into UDP, which is then encapsulated into IP packet. So this is UDP. As per RFC, the recommended port for UDP is 4789, and this is the outer IP packet. This would be containing the IP addresses of your source and or destination layer 3 interface IP addresses. So basically your ports over here on the switches, you can say leaf switches in terms of data center terminologies. These are spine switches. So leaf switches will have ports or different VLANs. These ports or different VLANs will be mapped to these VNI values, and our data or subscriber data or customer data layer 2 Ethernet frame will be encapsulated using VXLAN and travel all the way to its destination. In this scenario, since they will be encapsulated, so overlapping of VLANs for the customers or the tenants, it is a possibility. The interface, this is VXLAN interface. Since it is encapsulation, we can call it that it is kind of tunneling, and that is why these interfaces, layer 3 interfaces, are known as VTAP or VXLAN tunneling endpoints. Now there are multiple ways to configure VXLAN. One is that we can map one-to-one mapping. Like let's say this is a rack here and this is another rack, and this is, let's say, VNI defined on one of the top of the rack switches. So we can define that traffic coming from this rack, if it wants to go out on one-to-one basis, we will map it like this, and for the return traffic we will be mapping it like this. So this will be called as static mapping. Another one possibility is that we use multicasting. Let me just remove this one and draw a figure. Let's say we have these two spine switches, and let's say we have these 4 racks placed here, and on top of these racks we have top of the rack switches, which are called as leaf switches. So these are the leaf switches, and these are spine switches, and these are connected in this fashion to provide fully redundant connectivity like this. Now in case of multicast, what will be happening is that again these all will be layer 3 interfaces, no layer 2 will be traversing these switches. So once you have these layer 3 interfaces, this network, although for the demonstration purposes I will be using a switch here, and this will not be layer 3 switch, but otherwise these all will be layer 3 switches, layer 3 interfaces, and so your layer 2 traffic will not be able to pass through it unless some kind of encapsulation. Of course we'll be doing VXLAN, but for multicast traffic to travel through these, you will have to have some kind of multicast network enabled in here for efficient transportation of that multicast traffic. Since I'll not be using these switches as the multicast for this demonstration, we'll see that our multicast traffic will be easily moving onto through this spine switch. Otherwise you would maybe have to enable PIM protocol here, or PIM sparse mode or dense mode, whatever you want, but definitely you would have to have some kind of multicast network for efficient transportation. So that's enough theory. I'm keeping it short. Now let's just quickly move on to the practical implementation. Let me just remove this figure and bring up the topology, which is, let me just log into this. This is again the virtualized environment. I have installed FRRouting devices over here. If you have seen my video where I have demonstrated how to install FRR image as code, if not, I'm gonna put the link in description. You can check it out at how you can install FRR based machines, which are really lightweight, open source, community maintained software, how you can use that in GNS3. So these are simple topology that I wanted to show. This is the Ethernet switch. It's just plain Ethernet switch doing nothing, just transporting frames here and there. And these are two FRR machines, and these two are Alpine machines. All these four are being maintained in Dockers. So I'm gonna run both of them, rather all four of them, no problem at all. And once they start running, I'm gonna access, let's say first FR1 through auxiliary console, and then I am gonna configure the interfaces. Since Ethernet zeros are connected, this one is hiding a little bit. Bring it here. So I'll be moving our VXLAN frames onto this path, and we'll be encapsulating the traffic which will be generated by these end hosts. So come onto the terminal, and first thing that I want to do is create a bridge interface which will be bridging these interfaces and our newly created VXLAN interfaces. So I'm gonna type in IP link, oops, again, console, oops, it stopped. Okay. Okay. So IP link, add, this is the interface name. Its name does not make much of a difference, just for reading purpose I'm naming it BR0, and its type is bridge. This type is important. Next, I'm gonna bring this interface into upstate by typing in IP link set and device bridge 0 up. Okay, this is done. Next thing, I'm gonna give the IP address, because we are gonna make it layer 3. I'm gonna give IP addresses to these Ethernet interfaces. So to do that, I'm gonna type in IP address add, let's say 10.1.1.1 slash let's say 24, and device Ethernet 0. You can check the interface by typing in IP address show Ethernet 0, Ethernet, let me just correct this, Ethernet 0, and the IP address that we just gave, it is here. Next thing, I'm gonna create the VXLAN interface by typing IP link add name. This name again is locally significant, does not carry much value. You can name it anything. I'm just gonna call it, let's say, VXLAN 10, and type is important. Its type is VXLAN. ID is the VNI that we talked about, VXLAN identifier. Let's call it 10, and the interface that the traffic will be going out is Ethernet 0. The remote interface is 10.1.1.2. The local interface will be 10.1.1.1, and destination port that we talked about as per RFC recommendation, you can change it to any value, but I'm gonna go ahead with the recommended value, which is 4789. So I have created this one. I need to bring this interface into upstate as well, and maybe give them IP addresses as well to these VXLAN interfaces. So give the IP address just like we did before. IP address, add, and let's just say 20.1.1.1/24, and device is VXLAN 10. Now to see that, let's say IP link or IP -d link show VXLAN 10, and we see that this is the interface that we created. Its type is VXLAN, its ID is 10 that we created, and remote is 10.1.1.2, local is 10.1.1.1, which is our Ethernet 0 IP address. Okay, so this part is done. Now we are going to associate this VXLAN and the Ethernet port, which is connected to our host, to be the part of one bridge domain. To do that, I'm going to type in IP link or bridge control, add interface, and bridge 0, and the first interface is Ethernet 1, that is over here onto the switches. So make this Ethernet 0 part of bridge domain 0. This is actually what this command is doing. And the second command is bridge control, add interface, bridge 0, and VXLAN 10. So that frames coming from Ethernet 1 can be encapsulated onto this VXLAN 10. Now this VXLAN 10 is in the down state at the moment, as we can see from here. So to bring it into upstate, I can type in IP link set device VXLAN 10 and bring it into upstate. Now if I check the status again, we can see that now this is into upstate via this flag that is up. So we added, let's just quickly check, IP link show and VXLAN 10. We are interested to see that this VXLAN 10 interface, it is part of bridge domain 0, and likewise Ethernet 1 interface should also be part of bridge domain 0. Okay, so good enough. Now come on to the other machine and do the similar procedure here as well. So first IP link add, then bridge 0 and make it as type bridge, then bring it up, IP link set device bridge 0 up, then create the VXLAN interface. You can name it here differently than the other one. As I said, they are locally significant. The only value that matters is that VNI value, it should be same if we want traffic to interchange between these two. So IP link, first give the IP address onto that Ethernet interface. IP address add 10.1.1.2/24 and device is Ethernet 0. Then we are going to add the VXLAN interface by typing in IP link add name, let's also call it VXLAN 10, type is VXLAN, ID is 10, device is Ethernet 0, and remote is 10.1.1.1, local is 10.1.1.2, and destination port is 4789. Okay, that is done. Now give the IP address to this VLAN interface, VXLAN interface, IP address add 20.1.1.2/24 device VXLAN 10, and now bring this device up as well. So just change here VXLAN 10, and let's check IP -T link show VXLAN 10. We see that its flag is up, and we have the VNI value as well, and destination port that we also defined. Now make this Ethernet port which is connected to this host and the VXLAN that we just created to be the part of bridge domain. So again, same procedure, bridge control, add interface bridge 0 Ethernet 1 for the subscriber port, and for VXLAN we type it VXLAN 10. So that's it. Hopefully our communication should be able to work. I just need to give IP addresses to these Alpine machines. It's really easy. Just come on here, IP link, and our IP address add. Let's just give it an IP address of, let's say, 30.1.1.1/24 device Ethernet 1, and similarly onto this machine IP address add 30.1.2/24 device is Ethernet 1. Now if I try to ping, let's just open Wireshark, start capture. Now if I come on to my second machine, and if I try to capture traffic using Wireshark and ping the IP address that I just configured for my first host belonging to the same broadcast domain, I should be able to see the traffic going through encapsulated via VXLAN. So let's try to do that. Ping 30.1.1.1, and we see that we are able to ping. Let's just stop this and come here. So this is the packet that we sent. This is echo request going from 3112 to 3111, and we can see that indeed this is the original frame starting from down below 3112 to 3111. This is the original MAC addresses of our end hosts, and then we see that we have a virtual extensible LAN header or VXLAN header with a value of VNI as 10. Similarly, for coming back frame is the same, that because we configured it to be the same. So that is how we have configured static VXLANs to carry our traffic from one leaf switch to another leaf switch encapsulated via VXLAN. Now I'm going to change this scenario. I'm actually going to build up this topology again, and quickly we'll see that how we will be doing the same thing using the multicast. Okay, so I simply just turned off these two FRR containers and turned them on again, and now I connect to this one first, and I do up arrow and I see that all the commands are available, so I don't need to type them all. What I can do is, let me just show you one thing. cat/root, since I am in the root level, it is maintaining its history, which is .hash history. So what I can do is that copy these commands Of course, we'll not be needing all these because many of them are show commands. I'm gonna copy it into text editor here, and we'll be needing this, we'll be needing this. These are not required. Similarly, we'll be needing this, but this time device Ethernet 0. After this, I'll be adding as group. This is the multicast group that we are going to define. Let's just say I define as 239.1.1.1 as the multicast group. Destination remains the same. This remains the same. This is not required. This is just a show command, so I'm going to remove this. Then adding these two into the bridge, and rest is not required. So let's remove this one. So again, just to reiterate, creating bridge, bringing it up, giving IP address to the Ethernet interface, creating the VXLAN interface with VLAN ID of VXLAN ID of 10, associating it with the group, destination port of 4789, giving the IP address to the VXLAN interface, and binding the two interfaces to the VXLAN interface. Now just select all, copy this one, come on to here, and just paste it. And if I do show now, let's say IP -d link show VXLAN 10, we have indeed configured the VXLAN 10 associated with the group of 239.1.1.1. Now let's do the similar configuration for the other one, other FRR machine that we have there. Just change the IP address to here. Group remains the same, and VTAP IP change to 2112 here. Rest remains the same. Just copy it and connect to this one and paste it here. Okay, now let's capture traffic again. Ideally, there should not be any mapping. Let me remove this traffic. ICMPv6, I do not want to see this, so I'm going to filter out this traffic and see rest of it. So as I was saying that since these FRR machines will not be having any MAC address mappings at the moment, because I turned them off and turned them again, so their MAC tables will be flushed. So the first packet that we are going to see if we try to ping from this machine to this machine or either way around will be a multicast, which will be directed to these to the other side VTAPs. But most likely these are these would have been already assigned, because once we created the VTAP interface, actually I did not capture the traffic at that moment. What you would see that once you create that VTAP interface or VXLAN interface and associate it with a MAC address, with a multicast address, you will see that a message gets popped up and distributed through this switch to all the connected machines, because it's a multicast. And it will be saying that, okay, hey, I'm the new VXLAN interface created here. My multicast IP is this, which will of course be the same that we just configured, and my VNI is 10. So that mapping has already been done. Now let's come over here. Okay, this is the first machine. Let's try to come over here and try to ping. Bring this one in the background. Try to ping the other side, 30.1.1.2. Most likely it will not have the MAC address table of neither of this machine nor the other end machine. So the first packet that we'll be seeing traversing through this link will be ARP request. Although this is a layer 3 link at the moment, but we'll be seeing that layer 2 traffic will be moving on to that. So come on to here and try to ping it. And we see that indeed we are able to do it. Now let's come back here, and we see that it is okay. Maybe it was it was already holding that, or maybe once I booted them up, maybe it was holding that value. It did not generate the ARP. Otherwise, you would see once you start it, you will see that first packet would be ARP packet, because it will not have the I would say not have the ARP table or the MAC address entry against this IP address. So again, this is the VXLAN header. We can see that it is carrying traffic. What we can do is, it is possible that once you configure this the way that I did it, like these commands, once you are doing this command, this one, before that you start capturing packet onto the link, and you will see that as soon as you configure this command and you bring it up, this interface, by typing this command, it will generate that request that I was telling you, that it will be a multicast packet that will be sent through, which will be carrying the information of your VNI related parameter, like this is my multicast group and this is my value. So what happens is that once all these consider these, let's say, top of the rack switches, they have the information that which VTAPs are associated to which multicast group, and the MAC address binding as well. Let me show you if I can find that thing here. Bridge control show. This basically shows that what are the interfaces assigned to this this bridge domain, and the other interface, other command, maybe it's not available here. It's I think MAC show or show MAC or something similar. It's maybe not available here, but what it basically shows you is that what the MAC address it has learned on this bridge domain. So let's just say show MAC. Okay, no, it's not available there. But basically what this command would be showing you is that you will see that against this bridge 0, you will have all the MAC addresses, like MAC address of your locally connected hosts and the hosts which are learned through the remote ends, through the remote VTAPs. So it will be mapping a table where remote hosts MAC addresses will be mapped to the remote VTAPs. So first will be the first packet against which it does not have the ARP entry for the remote host. That entry will be like multicast, but then these will be, once the table gets populated, it will be the unicast addresses. So I hope you have learned something from this video. Actually, we talked about two types of configuration for this VXLAN. One was static and the other one this multicast. There is another one which is most advanced. It is based on BGP and it is called as eVPN or Ethernet VPN, which is this one is mostly used in large scale data centers. It is quite I would say latest technology, but I'm not gonna discuss this right now. The video has already taken long enough time. Maybe I'll try to demonstrate that in another video. I just hope that you have learned something about VXLANs and how to implement them on FRR, and I would really like to thank you for watching the video.